Hi, I would like to show you how you can find suitable DC motors for your applications. In this tutorial we focus on the speed and torque requirements for the selection of the right DC motor type. Once you have found the motor size, you will have to determine the matching winding. Please refer to a separate tutorial for winding selection. Starting point for motor selection is the motion of the load in the application. The necessary operation cycle, speed profiles and friction result in speed and torque requirements the motor has to fulfill. In case of mechanical transformation, think of gears and screws, the values at the load have to be converted to the motor output shaft. In our standard diagram with motor speed as a function of torque, this can be represented as points of operation. For example, there can be a constant operation at a given torque and speed. There might be an operation at higher speed but at lower torque, or maintaining a position against some external force at zero speed. Another possibility is speeding up with some mass inertia to overcome. Usually, that's where the highest torque occurs. Regarding torque, we condense all the operation points in a few key values: the average RMS load torque and the extreme operation point. Let's first look at speed. We need a motor with a speed limit that is high enough to cover all operating points. The speed limit of Maxim motors corresponds to the upper limit of the operating range diagram. However, it is essentially the required torque that defines the motor size. We have to select a motor that, on average, can produce the necessary torque. Hence, we need a motor with a nominal torque larger than the RMS average load torque. Short load peaks, as during acceleration, may be located in the short-term operating range. The maximum permissible speed of Maxim motors can be found in line 23 of the motor data. It is related to bearing and brush life considerations. The torque capability of the motor type is given as the nominal torque in line 5 of the torque data. It is a characteristic parameter for a motor type and size. It limits the continuous operating range. Essentially, it's given by a temperature limit. Up to this torque, the motor can be loaded continuously without overheating under standard conditions. A good overview of the nominal torque of Maxim motors offers the selection guide in the catalog. The red bars indicating the torque capabilities with respect to the scale at the bottom. You can also find here a lot of additional information, such as possible combinations with encoders, gears and controllers. Higher torques than nominal are possible, but only a limited amount of time. How long an overload situation may last depends on the amount of overload torque and the motor type. As a rule, the larger the motor, the longer the overload can be. Typically, overload can last several seconds, as indicated by the thermal time constant of the winding. Roughly speaking, a motor can support 2 to 3 times the nominal torque for periods up to this thermal time constant. In addition to these considerations about torque and speed, there are other questions related to the selection of motor size that need to be addressed. The first one being the mechanical interface. What is the maximum diameter and length that is possible? How is the motor going to be fixed? Are there any restrictions concerning the size of mounting flange? And how about the shaft diameter and length? In case a Maxim gearhead has been selected previously, we have to respect the Maxim modular system for the possible motor types in combination with this particular gearhead. And at last, service life and motor temperature might also have an influence on the selection of the motor type. Sometimes it is advisable to select oversized motor to enhance the life of the brushes or to keep the housing temperature low. That's it. A short introduction on brushed and brushless DC motor selection. Don't forget, the starting point for a good selection is the knowledge of the speed and torque of your application. Put some effort in it to find out at least approximative values. And good luck during selection.